Hi, my name is Trinway. I'm going to talk about easy computer vision and computer vision algorithm collection in CentOS Linux environment. I'm going to cover a list of topics as follows: the introduction about CVAC and easy computer vision, the installation and configuration of CVAC in CentOS Linux environment, execution of demo scripts, discussion about issues that I encountered throughout the installation and configuration process, and lots of resources that can be used for future usage. So CVAC is a DARPA-sponsored effort to collect, make available, and reuse computer vision algorithms. The effort was sponsored by DoD, already been paid for by DoD also. So CVAC is a data definition and server description framework. It provides an abstraction layer for computer vision data and tasks. In the diagram on the right hand side, computer vision algorithm collection is in the bottom half. The focus will be around the Java services and the C++ services. Easy computer vision is for vision users or the end users of computer vision algorithm. It allows the user to focus on metadata instead of the implementation of the computer vision algorithms. Therefore, it hides most of the generality and complexity of CVAC. In a diagram, easy computer vision is in the top half. It provides a set of it's called easy Python layer, or a set of Python modules that allow users to write a quick program that communicate or use computer vision algorithms that are available in CVAC layer. Now, in between, the system use Internet Communications Engines, or ICE in short. With ICE, it provides what is called a slice or specification language for ICE. This is the way that allows ICE to map from slice to Python mapping, or slice to Java mapping, or slice to C++ mapping. So the way that the application in Python can communicate with services through this ICE engine in a neutral way, or in short, could be transparent to the end user. Now, behind the scene, C++ services or Java services, depending on which service that the easy Python module communicate with. We'll talk to one of our C++ libraries on the server side. Here's a few of them listed here. Is OpenCV, or Open Computer Vision Library. LibArchive, this is for handling archiving or unzipping files. Matlab Runtime library. The installation of CVAC here will be into CentOS Linux. It's a 64-bit environment. So the best way to do this is to build CVAC from the source code. And here is the URL that talk about how to build CVAC. In short, I summarize it. There's a set of tools, compilers, libraries, or any additional packages that need to be installed in the system before we do a build, before we build a CVAC from the source code. So for compiler and tools, we need to install a set of development tools in CentOS. If the CentOS environment doesn't have those available, in this development tools, things like configure, make, GCC compiler, etc. will be installed into the system. Besides that, we need to install Java JDK, Since this is the 64-bit CentOS Linux environment, we will install 64-bit Java JDK. And in this particular case, we're using version 6, extension 45. And also we install Python version 2.6. This is what it is recommended by CVAC. And also, in order to compile CVAC's project, we use CMake. In this particular case, it's the version 2.8.11.2. Now, how to install development tools? We can install from yum repo, and here is the command that we can use to install. This is what I'm doing is a group installation. All the development tools are grouped by or stored in yum repo. That can be installed at the same time. Now, in addition to that, since CVAC using GitHub, so it's a Git repository. If Git tool is not installed by as a part of the development tools above, we can always install Git independently, separately, and this is the command how to install Git. After that, we will install Java JDK. Java JDK 64-bit can be downloaded from the Oracle website, and there's many ways to install and set up Java JDK, and below is one of the ways that I normally do when setting up this kind of environment. So from the URL, I download the .bin file for version 6 and make sure it's a 64-bit version. After downloaded, I will run it from the location where the file is stored, and after that I move it to the /op location, and then after that I will create a symbolic link from op Java pointing to op JDK 1.6. This is the way that I set it up so that it allows me to switch from one version of Java JDK to the other without making a lot of changes to my configuration file. After that, we have to install Python version 2.6. There's two ways to do it. We can always install from the source code, or we can install from a yum repo if it's available. Here is the command that allows us to check to see which version already been installed on the system. In this case, it's a yum-less Python. It will tell you what version being installed. And to install Python, the following command allows us to install Python into the system based on the yum repository. If it doesn't have the right version, then one needs to find the right version to install. In this case, CVAC recommended us to use version 2.6. After that, I will install CMake version 2.8.11.12, and here's a URL where one can go and download the source code. And after that, we just do a build from a command line, and here's the number of steps that one can do once they download the file, unzip the file, and then kick off the process. So let me just show it to you real quick. So in this Windows, I have CMake version 2.8.11.2 installed, and if you remember from the slides, if you use the configure command first, you're going to kick off the job and let it run. It's going to take a while to collect information. Oh, it's done now. Then it says I can run either make or gmake. In this case, I can kick off gmake here and pick up the task to build the tool, and then after that I can do a sudo make install CMake into the system. In this case, I already installed it, so I don't have to do that. After CMake, we go into work on the dependencies for the source code or libraries. In this case, CVAC requires the following libraries: OpenCV or Open Computer Vision version 2.4.5, ICE version 3.4.2, and libarchive version 2.8.5. In order to install OpenCV version 2.4.5, one can go to the URL to download the source code. Make sure you download the right version. This is the version for Linux/Mac. And once the file is downloaded, unzip the file and use the instruction in this box to build OpenCV. So let me show you real quick. So over here I have OpenCV version 2.4.5 already been downloaded and unzip it. So to install it, run this command to start. So I'm gonna let it run and go back to the slide, and we come back once the job is done. And then after CMake, make sure you cover run CMake with a dot here. And then after that process done, we run make and do a sudo make install to install OpenCV into the system. After that, we will install ICE version 3.4.2. Here's a URL that one can go to download this version. In this version, recommended by CVAC, and in this version, at this location, one can download the compressed file. When I open this compressed file, there's a set of RPM files inside, and to install each RPM, one can use the following command: sudo rpm-i and then the RPI file name. Okay. So let's go back to this window. OpenCV, which I run a CMake, so now we can run make to let it build, and that's how you compile the OpenCV source code there. And let it run. Go back to the slide, and after that we will compile libarchive version 2.8.5. Here's the URL that one can go to download the libarchive source code, and make sure again use the right version. In this case, we're interested in version 2.8.5, and similar to other source code, we follow the following command from the install file: config, make, and then sudo make install to install the library. Now, why do I give you a specific version number? These specific version number either explicitly recommended by CVAC website or by other route that I found it later on, and in the later slides we will talk about some of them, but let's take a look at the dependencies page for CVAC. On this page, one can see that it's explicitly specified here. For libarchive, it's best to use version 2.8.5. Now for ICE and OpenCV, we don't know the exact version here. So this is the thing that people, when they install CVAC from the source code, have to be very careful with. And here's an instruction using yum to install dependency for Red Hat or CentOS in this case. In my experience, depends on the yum repo that you have in your system. Be careful when you run this command, because with this command it will try to install the latest version into your system. For example, with CVAC, with ICE, it is recommended that you're using version 3.4.2. But when we use the yum command, install version 3.4.5, I believe, and they are not the same. So it will affect the way we configure CVAC when we run CVAC. I will touch base on that one when we get there. And the same thing with OpenCV. There's no mentioning here, but later on when we run the demo script, in there it will tell us that some of the models was built with a specific version of OpenCV, so therefore we should use the same version in our system to avoid backward or forward compatibility. Let's go back to the presentation. So after install all the dependency, we go to the additional packages that we will need for when we run or use easy computer vision packages. One of the libraries that require is called Python Imaging Library. In this particular case, current version is 1.1.6, and also we need to install Matlab compiler runtime version R2012B. Make sure select the 64-bit version. So how do we install Python Imaging Library? Here's a location to go and get the information. But to install it, we can install from the source code, or we can install from the RPM file. For this particular exercise, I was able to find the RPM file at this URL. When you get to this page, the instruction below describes exactly what one has to do in order to install Python Imaging Library into the system. So follow this instruction. It will allow you to install Python Imaging Library correctly. Next is Matlab compiler runtime. For this particular one, here's a URL that one can go to and download the, in this case, a zip file, or you can use the URL below to get to the zip file directly. But again, make sure it's a 64-bit version for Linux. Just don't download the Windows version or 32-bit version. To install it, take a look at the readme.txt file inside of once you unzip the file, and the only command that you have to run is /install, and it's a GUI installation. So just follow the installation, and it will install to the default path if you did not change the path. And then at the end, there's a screen that will tell you here's a few things that you need to add to your system configuration. So make sure you copy the path down correctly, so that we can use it later in our configuration. So after we install all that, the next step is to download CVAC source code so that we can do a build. So this is the command that we can download the source code from GitHub. So this command allows me to make a clone of the CVAC Git repository and store it in a directory called CVAC in my system. After I execute that command, CVAC source code will be downloaded. Then I go inside of CVAC directory, and I can run the git status to see which branch it's using. So by default, whenever, in this case, when I clone the git repository, it uses the master branch by default. But in our case, we need to use the development branch or devel branch. And here's a command to switch from the master branch to the development branch. When we do that, the directory on the right hand side, that's the development branch look like. In this branch, the difference between the master and this development branch is one of them really stand out is a demo directory, and this is where all the demo script reside, and written for this particular version of CVAC. So it's better that to run the demo script in the same source code that it was developed with, instead of taking a copy of the demo script, move it to a different branch and test it out. Sometimes it might not work, so make sure we use a development branch in this case. So now we're ready to build. No, not really. Before we can compile CVAC source code, additional thing that need to be taken care of. One other thing is we need to add the third-party jar library files to the project. And the way it works is create a directory for third party, and inside of third party create another directory called lib, as it's shown in the diagram on the right hand side here. And then there's a number of jar files that need to be copied into this directory. We will cover that in the next slide. And after that, we need to set up a few environmental variables for CVAC specifically before we can build CVAC project. And in this case, I create a file called setenv-cvac.sh under the bin directory of my root account here. Okay, so here is a whole path. So here's a list of third-party jar library files. In order to compile CVAC source code, I need these jar files. In theory, unfortunately, these jar files not in the Git repository. The only way that you find out is after you, the only way I found out about these files after I run CMake. I will cover that later on, but this is the list of jar files that I had to put in that directory. So for a common IO 2.4 jar file, one can get it from the URL below. You unzip the file and the jar file is in there. The next one is called javatar-2.5.jar, can be found at this URL here. Again, unzip the file. One can find the jar files in there. Next one is labelme.jar. This is very tricky. I couldn't find it anywhere. I couldn't find the source code nor the jar file. And luckily from CVAC wiki page, I was able to go to download a binary installation for Windows. So when I run that in Windows environment, I was able to obtain the labelme.jar file. So I copy over so I can use in in this case to build my CVAC project. And the last one is called javabuilder.jar. This is one of the tricky one. There's no version attached to it. So what happened was I found a copy from somewhere, I don't remember. I did a build, failed, even though the jar file is in the right directory. After digging around, I found out that the file that I have at that time was a wrong version. I can get to it from the Matlab compiler runtime. So here's the path that one can find this javabuilder.jar file. So whatever version that Matlab compiler runtime install in the system, one needs to go to this location to get the javabuilder file, copied into the third-party library location for compiling or building CVAC. So after copying the right jar files to the third-party lib directory, the next step is to create the shell script so that we can set up the environmental variable specifically for CVAC so that we can build CVAC project. And here's a list of in this particular instance, this is where things get installed. So for eyes, this is the path in my VM for OpenCV, and this is the path where things get installed. For Matlab compiler runtime, this is the top level directory path, and then in there I create a Matlab compiler runtime. The runtime specifically, I need this later on. I will explain to you shortly. And then when you finish the installation of Matlab, there's a window that pop up it says make sure we have copied out these two things, and let's see what they are: the Matlab MCR and the app folder. It will go into this setenv-cvac.sh file. Next, I need to set up the lib directory. This is the system lib directory where some of the libraries file exists. And then there's a lib64. This is where all the 64-bit library reside. And then for compiling, we need to set this LD library path. And in this case, we would like to point it to things like cvac lib location, lib location above, lib64, and then Matlab compiler runtime. Cvac lib will be defined in the next slide. And after that, we need to update the path environmental variable. One case it point to cvac home, another one point to IC or ICE home, OpenCV home, and Matlab compiler runtime location. So in this slide is for cvac related. So we need to set up cvac home. In this case, basically from the whatever that default account I have, and I put out cvac directory here. And also I set up cvac lib that point to this location, and then cvac lib external, and this is where all the third-party libraries exist. And then after that, we set up the environmental variable for Java related. So this is the Java home. Remember we did this for when we installed Java JDK. So by using the symbolic link Java here or /op/Java, if I need to switch Java from version 6 to version 7 or different version within version 6, like right now we're running 6U45, but let's say later on they updated to U46, we only updated on the op location and rewire the symbolic link, and I don't have to go back in here and change this Java home value at all. So that's the beauty of it. And then we add the Java home bin to the path so that we can access Java command from the console. Now with Java, it requires it's good practice to use the environmental called class path, where we set up all the Java parts that it needs and put it into this class path, so that when Java apps running, it can look for these Java library files from the class path. So the first one we use is ICE. The second and third one is cvac related, but we won't get this until we compile cvac. So when you will see that shortly. And these are the third-party library Java file that we covered earlier. And lastly, I think this is about Python. So if we install Python from the source code, we might have to set up the Python home environmental variable. But in this case, we install Python on RPM, so it automatically set up Python for us in the system. We don't need to do this at all. And next, we have to set up the Python path. This is where we want it to include cvac related Python code and library in there, so that when we run a Python application, it will be able to access cvac specific Python script. Okay. Now we are done. We're ready to compile cvac source code now. Let me quickly go through this and then I'll show you what to do. First thing is, assuming we go to cvac location. This is the location where we put out the Git repository. From there, we call this script to set up the environmental variable for cvac before do a build. Make sure you run it with a dot in front. That means whatever environmental variable set inside of the shell script will stay with this console. And after that, we run a cmac dot to initialize the project and make to build the project. And after we're done, optionally, one can run sudo make install to install CVAC module into the system, or we can run CVAC directly from the root directory. So let's go back to the console. I'd like to show you how to build CVAC. So this is the location where my CVAC exists that I put out from the Git repository. So let me show you a little bit about the directory structure. I create the third-party library here, and I add or move all the jar files in there so that we can see these are the jar files. And then it has a data location, and it also has a demo setup demo script that we will execute later on, so you can see how things work. And pretty much that's it. So let's do the build here. So from the slides, we run the cmac dot command to initialize the project. So what happened is we check to make sure it has the right compiler: C compiler, C++ compiler, Python, ICE, lib, archive, OpenCV, Java, so on and so forth. Okay. And after that, we run make to compile the project. So the first thing it compile is it generate the .java file to a iSource. This is what it's doing the slice to Java mapping, and from there it build core first.java file. And after that, it build the CVAC slide Java file, and then it build a file server Java file. Sorry, keep rolling. And then after the Java services, it build the C++ services. You can see it compiled a C++ code turned into these object file, and then it also generate Python file, but these are ICE specific. These are sliced to Python mapping modules, and then it generate other services we needed. These are again C++ services. And give a few more minutes, second is done. So basically the project is done now. We can run the command sudo make install to install all of these into the system, or we can process the system directly. In our case, we won't run the install, we want to run it directly from the directory where it's built. So here is the screen that I same location. I'll show you that. Right now, remember in the hold on, let's go back to the slides first. So we just finished the build. We noticed that it create a directory called bin. In there, there's two files: starticebox.sh and stopicebox.sh. And then a lib directory with a subdirectory called Python. This is where all the CVAC related Python module are stored. Before we run CVAC, we need to configure CVAC shell script. So the starticebox.sh is a script allow it to start CVAC. Stopicebox.sh allow it to stop CVAC. In this particular case, I would like to move these two files from CVAC home bin directory to my home bin directory, or from this location to this location. Okay, and then I modify one at a time. I modify the starticebox.sh first. The idea is utilize the environmental variable that I already defined and set up in setenv-cvac.sh, so that my starticebox.sh file now will be very simple, not complicated. As you can see, I set up or initialize all the environmental variables there, and then go in and deploy C++ services, and then the Java services here. Now for Java services, I need to include this info into the command line, so that at runtime I'm able to find Matlab compiler runtime library, and this is needed when we run the a demo script later on for when we build the label me corpus. Okay, and then next is modifying the starticebox.sh. Similar to starticebox.sh, we'll take advantage of the environmental variable we already defined and set up in setenv-cvac.sh, and then all we have to do is kick off the command to shut down both C++ and Java services. So let me show you how that works. So pretending this on the right hand side screen here, that I'm going to start cvac, or I execute the starticebox.sh command, and it's located at my home bin directory. Kick it up, as you can see, it launches the service, and then it launches another service. These are C++ services. It launches another service here, and it launches another service here, and after that it launches the Java services, in this case a corpus service, and then another file or Java service called file service here. Now to stop it, we can run pretty much the command from anywhere. So I'm going to run it from the left hand side window here. Issue the starticebox.sh, hit enter. You can see it stopped all the services. These are the C++ services, and these are the Java services. That's all we have to do. Next. So I just demonstrate that we have two consoles. One, we run this command to start cvac services. On the other window or console, we run this command to stop cvac services. And I just did the demo too. Now next, we're going to cover execute some of the demo scripts to demonstrate now the system or cvac is being built correctly, and we can start the service, and then we run these demo script to show that it's working, and its script will do different things. Okay, there's a write-up about our tutorial posted at this URL here. That I think recommended you should go there and take a look. I will describe in detail about what each Python module here does, and what how it builds a data set, or how it when it executes what it does, and how it builds, let's say, the full image corpus. This script showing how to get a collection of images or annotated images from Label Me website and build a corpus. And this script shows how to utilize remote services. Okay. So let's go to the demo. We're gonna do the same thing. We have two consoles, and console one will run the script to start cvac services, and the other script we just set up the environment, and then we run the demo script from there. So let's do that. So imagine I have these two consoles. The left one I'm going to use to run demo script. The right hand side I'm going to start cvac services here. So to start CVAC services, I issue this command to start a service. On the left hand side, remember I have to run this command. Oops. Sorry, wrong path. This command to set up the environmental variable specifically for CVAC, and enter. So everything's set up. So let me show you the list of demo script that we have. They are in demo directory. Anything in with py here, but pretty much we will run those. I will run a few things. I will probably run the standard set first from the tutorial, and then if we have time we can run additional set. So the first thing that you should do to make sure the Python modules are installed properly, then you run this, execute this demo script called prerequisites.py, and what it does is it verifies Python library or module for ICE, OpenCV, CVAC, pass, and easy install and properly. If it fails, you will see the error message here instead of succeeded. The next script that we can run called training, and you can see when we start the demo script, the right hand side window here will process whatever the left hand side trying to do. So imagine the right hand side will be the server side, the left hand side could be a client side, and as you see they're both communicating, and the left hand side just done. So the right hand side done, waiting for the next request. So what we just did is we ran the training py, and let me walk you through real quick and then get an idea. In this case, we use set up data from training image directory to create they call a training run set with the purpose call or class ID of 0. So in this case, under the CA subdirectory, there are 5 images, and it found and labeled with CA. And in the other subdirectory for KR, it found another 5 images and labeled them with KR. And another subdirectory, US, it found another 5 images, and they're all labeled with US. Then from there, it tells the service to say add the number of images that found per subdirectory into a training class and label with a number 0, 1, and 2 for 3 different sets. And then from there, it try to create a train model, that's what it's called. And then on the server side, it build and ship it over, and the data is stored at this location as a zip file. Now in the zip file, this is the model, trained model that generated by the server. It has the model in there. In the zip file, here's a list of files in the zip file. Okay. And later on, we use that to test. So the next set is test the run set. So in this case, instead of using images from train image, it use images from test image and test it again the run set I just built. And then as you can see, here's the name of the image to send in, and send in 1, 2, 3, 4, and 5, and here's the result. For US flag, it found 1 unlabeled 2, which is class 2 over here. KR flag, it found 1 and then label 1, which is in this area here. Italia.jpg, it found 1 in label 1 somewhere in here. There's a corporate logo collection JPEG, it found 1 but in label 1 again in this set. there's a CA flag found in label 0, which is up here, and so on and so forth. But as far as identical labels, there's none. It found something in there, but not identical. So let's move on to a different script. This is called bootstrapping. Run it, and you can see both client servers working. You can see the client, which is the left side window, send a request to the right hand side, and then the right hand side process the request and send it back to the left hand side. That's the idea. And then we can run the next one called detect-py, and it's very short. Basically, it tries to run process an image, again a pre-exist trained model, in this case called a bag of words, and then generate a result. That's all. And then let run another script to do to build the corpus for a full image set. So let it run. So in this case, it's building corpus from 3 different data sets. Let's see, from the training set. Oh no, right here. From the corpus 1, we have 3 label artifacts, and this is the name. And it found CA flag, KO flag, and US flag, and build a second corpus with this name under this directory, and then so on and so forth. You can read the detail about how this script works in the tutorial that I post the link on the slides for more detail. But in general, it just allows us to build image corpus from a collection of images that we have. Could be anything that you have. So the next one is very important. This module allows us to connect to Label Me website, pull out a set of images, and build a corpus out of it. I will touch base a little bit about Label Me later. So the idea is, what happens behind the scene is, as you can see on the server side, it makes the connection to Label Me, and then pull down a set of images based on what we configure. I will walk through that process really quick. This image just pop up. Basically, it's an image from Label Me based on a data set that we specify in the properties file. What you see in here is in the image, a shape of a car already been annotated with a red line around it. You can see the red line cover the entire car, and also cover a license plate, because that's what we're interested in. And it looks like this set has about 21 images. So let's see, let's show another set, another image in the set, another one, another one, another one. So we have to cycle through 21 images here. Okay, so that's it. So in this set, according to the code, it found 9 license plate labels and 27 car related labels. So those pictures with the car annotated with red lines around it, those are the 20. We found about 27 car related labels. It doesn't mean 27 images. One image that you get, if you remember, some of the images have more than one car. And then the same thing, the license plate on each car, in some image very visible, some of them not. So the one that can see and annotated is how about 9 license plate label there. And the last one is for remote services. So let me see. Let me go back to the demo script to load the remote. Let me turn this one on first. By default, the source code will, the demo script will try to connect with this server, which is the remote server. let's see what happens. And then I will switch to the other host later. Okay, so let's run remote servers. So in this case, what we're doing is we run it from one end, trying to communicate with the services remotely. Now in this case, fail, and here is the error message. What it looks like. Just want to walk you through quick, and we will talk about this in detail later on. You can see from the error message, the error starts from the remote service.py, which is the script that we just ran, and then from here, the error trickle down to easy.py module. This is the easy computer vision Python module that remote underscore services py try to talk to. And then from easy py it goes one level down to files underscore i.py. This is the slice to Python mapping module. And then from there, at line number 469, that's where the arrow curve, and here is the exception, the call file service exception. It's not clear. It doesn't say it couldn't connect to the server. On the services side, it did say, let me see, it just say try to connect to nothing. Actually, nothing happened here. I just say actually these are the messages from the earlier run. So this error message is not really helpful. So what I'm going to do is I'm going to switch it to my current host machine, which is this IP address. So let's make sure it ends with 114. Okay. So this is the current IP address in this machine. So let's run that remote service demo script again. Now in this case, instead of communicating with a real host somewhere else, we communicate with another host. In this case, a local host. As you can see, there's something going on this side here. It build the training set and process the data and then send it back here. That's how the remote service is working. So if the other host open up, then we can communicate with our host and have that host process the data. This is very useful when we need to communicate with a host that have plenty resources that are capable of processing large data set if our local machine can't handle it. Okay, so that's pretty much the demo about script, the default demo script that comes with the project. And as you can see, they are working. Easy to make them working, not difficult. Let me cover this a little bit. So let's look at the demo script source code. Remember the first one that we ran called prerequisites. You want to make sure all the Python modules are installed correctly and can be imported properly. And this is what the code looks like, very short and simple. And then training demo script, and as you can see, the source code very short, simple too. Some of them it seems to be very self-descriptive, like create a run set from this directory, and then get a trainer from this service, and then after it has a train set or a run set and a trainer, it will train them together to create what I call a train model. And then after it train a model, it will get the model and zip it up and store it in the path here. And after that, it will create another set, in this case called test set, from this directory. Remember the train set from the train img location. This is the test set, and with the test set, it will try to get a detector from this service, and then from there it will run the test set here against the train model, which is coming out of the training set of images here, and return the result, and this just print out the result. So it reduces a lot of complexity and transparent to the end user in this case too. They don't need to know at the end there's a Java or C++ service that I need to talk to. I just write a simple Python code like this and able to process the data. The label me corpus here, very interesting one too. First of all, it accesses there's a properties file at this location, and then from there it will try to get the data set from whatever information in here. Let me walk through the source code first, and then we go to the properties file, and we're going to talk more about it. And then after it gets the set of data, print it out, make sure that we have the right set, and then it draw the label or apply the annotation to the image. Remember, we see the images with cars and with the red line annotated around the shape of the car, and that's what it's doing here. And then in this case, the next slide, we're looking for a license plate. Any category that starts with license plate, do a display to find out how many license plate label, and then look for the categories and then start with cars and display it. You remember we display the number of license plate, number of car, and then quit right here. Basically the program stopped right here. Because of that, we didn't go into the other code here to test out the training set, but it can be done. Just uncomment this line out and the program will run. That's all. So let's look at the properties file that we can see here called label cars test property. It's in the data location under corpus label car test properties. So this is the configuration of properties file that will the program use to go and get the set of data from label me, and it's very simple too. It's a label for the data set. Here's the URL to go there and get it, and then here's a folder name that will drop on the server, and here's a number of object names, and that's all it does. That is what comes with the source code. And let me show you how to get the information. So for label me, this is the URL that one can use to get to. Let's copy it. We go here, paste in here, there. Get to the front page. In this case, one need to create an account. I already have an account with them, and from there I go to our public collections that are available to anybody. So in this case, it's a list of public collections that one can look through. There are plenty of them here that one can use. Let's go back to the config file that we have. It uses set call static car text square lot. Okay, go back to the website. We look for that static car text square. Okay, this is the one. So click on it. Show you a list of images here that are being annotated. Okay, so this is the image that get downloaded into my VM when I execute the label me _corpus.py demo script. Now if you remember, in the properties file, they specify a few things called object names here, like car, wheel, camera, license. Where do they come from? They come from this called collection stats. When you open it up, you will see here's a list of object names available. And you remember there's a car, there's a wheel, window, and license plate or license. So here's where they get the name from. So they take this name, put into this object name here. So when we run the label me underscore corpus, if we pull out data from this collection and then look for these things. Okay, so that's how it works. So similarly, I build another set, and this here I call kitchen test right here, and it points to a different folder called August 1 static KPM kitchen, and here is the name of the folder, and here is the object names. Okay, make sure you get the right one, and pretty much the same thing. So I already built that up front, and then I took a copy of this label me underscore corpus, turn it into label me underscore corpus dash kitchen, and modify a little bit. Certainly the first one is point to the right properties file. In this case, the label me kitchen test properties, and then apply some of the object name there. In this case, I use merge because that's where I can find from the collection. And then any category start with handle, I try to print it out too. And then let's run it, see what happens. So in this case, I will run label me kitchen. So very similar to the other one. This process will connect to label me website, put out a collection of annotated images, and you can see the first image show up now. We got about 13 total. Let's cycle through. 1, 2, 3. You see annotate different objects inside of these images. Okay, done. So that's all you have to do to get a collection of images or annotated images from label me to build a corpus, so that you can use with other demo script to detect, images against this corpus. That's pretty much done about demo script. Let's talk about issues that I have with this projects when I try to build and install CVAC from the source code into CentOS Linux environment. So the first issue that I have with is a CVAC dependency. As mentioned earlier, make sure we use the correct version as recommended. If they say you have to use version 1.2.3, make sure you use version 1.2.3, even though the latest version is not 1.2.3. Again, try to use the right version, otherwise you might get some unexpected exceptions. And then be ready to find the dependency of the dependencies. Like for example, when I first build the lib archive project here, it requires a few other libraries, so make sure be able to find them either through Google search your friend, and then use yum command to look for it. The next one is related to ICE. This is the Internet Computations Engine. Again, if we use yum command, the default installation will put out version 3.5. And the first thing will fail is when you try to start CVAC, it will fail because it couldn't find this class at all. Now, by default, we only include ice.jar files in the class path. For version 3.5, they move icebox.server into a different jar file, and that's why it failed. And again, that's why we need to use a correct version. So in our case, I think we use version 3.4.2. And then next one is about OpenCV. Make sure we use the right version also. The reason is when we run the demo script, one of the pre-built model files was built with OpenCV version 2.4.5, and then if we build a project with OpenCV with different version of OpenCV, when you run the demo script, will tell you that too. Say the model file was created with a different version of OpenCV. So in order to avoid that, for this particular case, stick to OpenCV version 2.4.5. The next set of issues with third-party library. If you remember that I mentioned earlier, there's a number of jar files that we need, but I didn't mention anywhere. The only time that I found it when I run the cmake command, will tell you. Sometimes I tell you there's one missing. You put a one in, and it'll tell you the next one. Some cases it will tell you everything, and that's good. But then you need to go find it again. Make sure you get the right version, the right Java. Specifically Java Builder for Matlab compiler runtime. And then if you're not familiar with Java development, then you need to do a Google search and figure out how to configure it to make sure all the Java files are accessible when Java services started. In my case, I'm fairly familiar with it, so I know exactly what to do and how to set it up, so that it will minimize, the number of errors that I might have to deal with. Oh, again, this is the Java Builder jar from Matlab compiler runtime. Again, make sure we use the right the Java Builder jar file come from the version that installed in the machine, not from anywhere else. This one is challenging. Label.me.jar. I couldn't find a source code or the jar file from anywhere, and all of a sudden I remember I saw the CVAC installation for Windows, so this file should be in there. So when I found a copy, and that's what I've been using. Without the CVAC installation for Windows, I guess I have to talk to the owner of the Git repository project to get the file. And after all that, the next issue that I have to deal with when I compile CVAC project is I'm using cmake, not make. So I'm not familiar, so it took a while to figure out what to do. So with cmake, it requires, first of all, cmake command line install, or sometimes you can use ccmake also, similar version. And then the build equivalent of the build file called cmake list.txt. Might not be able to understand all the syntax, but take a look at it. There might be something in there that we need to do. And yes, there's something in there initially I didn't have, and it failed on me. In this particular case, in the cmake list.txt file, there's a flag that we have to turn on if we were planning to use label me data. By default, some of the, I don't remember whether the master or the development branch, this option is off. So when I execute the label me underscore corpus Python demo script, it failed because the Java services was built without label me modules in there, and that's why it's failed. So make sure you turn this one. If it's off, turn it on. Then the Java service will be built with the label me related module in there. Then it will work properly. Lastly, this is the list of issues with demo script. So I ran the detect.py. It needs additional services to be running. At least in the Linux case, I was able to turn it on from cmake-list.txt. I got this service built and deployed, but I couldn't find this service. I didn't want to spend time on it later. And then for similarly for label me corpus.py, besides to make sure the Java service is built with label me modules in there, it requires a Matlab compiler runtime, which is a C++ library. Otherwise, we get an error too, and it looks like the default script doesn't have it in there for some reason. And another problem with the demo script is the remote services that I pointed out earlier. When I try to run it and try to use a default host in the Python module, I tried to connect to vision.mps.edu and it failed to connect, but the error message didn't say that. It did say invalid physical path. It should have say unable to reach host or remote host. Then at least we know what's going on. And not sure whether the server is down or not, but inside of that module, it needs to communicate with that host via these ports. So if the port is not open, then it will fail to connect to the host, remote host also. So if you have this kind of setup in your environment, it's recommended to open these ports up at the firewall level or the IP tables for CentOS Linux environment. And then lastly, on the remote side, this service needs to be up and running too. Otherwise, it will fail. In my demo, I have this service available and running, and that's why I was able to demonstrate it successfully. Next issue is about troubleshooting with demo script. The diagram on the right hand side here is a simplified version of the diagram that I show in the in the introduction slide, where we have a demo Python script at the top, and it talks to easy computer vision layer, and from there easy computer vision will talk to CVAC neutrally in a way through the ICE layer. Remember those slides to Python mapping, slides to Java mapping, slide to C++ mapping. So now we run the demo script at the top. If you remember, there's an error that occurs when we run the remote underscore services demo script. The error is one thing, but in reality it's not the same thing. And if remember, we trace it a little bit, we can see that there's the error occur at one other line in the demo Python script, which call a method in easy module, and from there easy call the slides to Python module, mapping module, and then from there it just disappears. It doesn't say which one down in the CVAC level caused that problem. So that's kind of hard to debug the problem. Now sometimes we're able to see the exception they thrown at the Java layer. Then what we need to do is locate the Java module, examine the code, insert the debugging message, recompile CVAC, relaunch CVAC, and then rerun a demo script. Then we can see what's going on more. So let me show you that. Now in the source code, at the top level, this is what it looks like. So under source, under CVAC, there are two things. These are the Java services, and this is the Java module that I'm talking about. So if the exception thrown at this level, one have to go in here and put in something kind of like this to add additional debugging messages so that we can see what's going on. and after we put in, we have to recompile and restart the servers in order to see the end effect. So similarly, anything under corpus servers, one need to go in there and find out which module, insert debug messages there so that we can troubleshoot the problem. Similarly, it will happen in the C++ services. We have to do the same thing. So a little bit challenging when we try to troubleshoot from the Python script, because sometimes the actual error is not at that level, it's at the lower level. It could be in the lowest level, could be the CVAC level here. So that's very challenging there. So to conclude the presentation, easy computer vision makes programming simple and easy to learn. As you can see in the demo script, the code very simple. A few lines of code do a lot of things already. So yes, it's a simple program, or a simple way to do programming, but in a fairly complex system, as you can see. To the vision user, it's transparent, but when the error occur at the lower level, it's a challenge to troubleshoot the problem. One of the benefits about using easy computer vision is it allows users to focus more on data analysis. Like we use different training sets, different test sets, run it against the trained model to see the result instead of writing computer vision algorithm there. As far as document wise, would be nice that CVAC document could be improved there, especially the build instruction per version of per branch, like the master versus the development branch. They're not the same, so a detailed instruction would help, and it will reduce time to build and install and running CVAC properly. So here's a list of resources that I've been using for the demo, for the slides and for the demonstration. Certainly one should go to Easy Computer Vision to learn more about Easy Computer Vision, and then from there one can visit the Git repository where one can get the source code of CVAC, and then along with other documentation, and then along with the FAQ too. So that is conclude my presentation. Thank you for your time. Bye bye.